Today, we're diving into the story of a single, tiny component that tells a massive story about a nation's ambition. It's small enough to fit in the palm of your hand, but believe me, its implications are absolutely global. We're talking about the Vikram 32 microprocessor.
And that really gets us to the heart of it, doesn't it? How can one tiny little piece of silicon, a chip designed for the most extreme environment you can imagine, actually signal a huge shift in a country's technological and strategic power? Well, let's find out. So first, let's get properly introduced to the star of our show, what's being called India's new digital diamond.
And here it is, the Vikram 32. Now, this is not just any old processor. It's India's very first completely homegrown 32-bit microprocessor that's been specifically built and qualified for the crazy demands of space. It made its big debut at the Semicon India 2025 conference, which was a huge moment.
You know, to really get why this chip is such a big deal, you have to understand this analogy from Prime Minister Narendra Modi. He called semiconductor chips digital diamonds. And that phrasing is just perfect. It nails their immense value, they're incredibly difficult to make, they're rare, and they are absolutely essential for any modern economy or military. So, looking at this, you can see the Vikram 32 isn't just a small upgrade. We're talking about a major generational leap. I mean, going from a 16-bit to a 32-bit architecture is already huge, but look closer. The new chip adds support for 64-bit floating-point operations. That's crucial for super complex math, like figuring out orbital trajectories. And it's already been proven on a recent mission. It's ready for prime time. Okay, so let's translate some of this tech speak into what it actually means. That 18-nanometer process might sound old compared to your smartphone, right? But for space, toughness beats raw speed every time. It's a proven, super reliable technology. And that temperature range is just insane. It means it can handle the freezing cold of deep space and the blistering heat of direct sunlight. And a custom instruction set architecture, that means India has total end-to-end control, no relying on anyone else's tech for its most important missions.
Right, so a chip like this doesn't just appear out of thin air. It's the product of a massive nationwide strategy. Let's take a look at how this one little piece fits into a much bigger master plan for self-reliance. And the engine behind that whole plan is this: the India Semiconductor Mission, or ISM. It was launched back in 2021 with a goal that is frankly incredibly ambitious: to build an entire domestic semiconductor ecosystem literally from the ground up. This is a huge piece of that wider Atmanirbhar Bharat, or Self-Reliant India, campaign.
And this isn't just talk, not by a long shot. The government put its money where its mouth is, with an initial commitment of 76,000 crore rupees. That's over $9 billion US. A number that big sends a very, very clear signal to the rest of the world about how serious India is.
The goal here is to become what's called a full-stack nation. India isn't just trying to get good at one part of the puzzle, like chip design. No, the mission is to build world-class capabilities across the entire chain, from the initial design to the mind-bogglingly complex fabrication in those fabs, all the way through assembly, testing, and packaging. The key is controlling every single step. So yeah, while the Vikram chip is a fantastic win, it's really just the tip of the iceberg. The real story here is the massive industrial foundation being laid to support not just this chip, but countless others for years to come.
And the scale of this whole thing is truly nationwide. We're talking about 10 major projects already given the green light, powered by a total investment that's now over 1.6 lakh crore rupees. That's almost 20 billion US dollars. And it's not all happening in one city. This is a strategic build-out spread across 6 different states, covering everything from those huge fabs to other specialized plants.
And this really shows you the diversity of what's being built. You've got the huge Tata fab in Gujarat, a critical assembly and testing plant in Assam, and even a specialized compound fab in Odisha that's going to make chips for things like missiles and electric vehicles. See, it's not just one big factory, it's a whole strategic network.
And here's the thing, this whole manufacturing push is being built on an incredible foundation that already exists. Something like 20%, 1/5 of all the chip design engineers in the world are already based in India, working for global tech giants. The goal now is to plug that immense brainpower into a homegrown manufacturing ecosystem.
So, all of this brings us to the final piece of the puzzle. What does this all mean for the future? And what does it mean for India's place on the world stage? This is where the strategy gets really clever.
See, alongside the Vikram 32, with its super secure, custom design, ISRO also developed another chip called the Kopana 3201. But this one uses an open-source architecture. It's a brilliant two-pronged approach. One track for ultimate security on government missions, and another to spark collaboration and rapid development in the wider tech world. It's just smart.
This quote from Union Minister Ashwini Vaishnaw really sums up the message India's sending out. In a world with shaky supply chains and all sorts of geopolitical drama, the pitch is simple. India is positioning itself as a stable, reliable, and growing hub for high-tech manufacturing, a lighthouse.
And you know what? It seems to be working. This isn't just a local story anymore. The global giants are taking notice. We're seeing a planned $400 million investment from AMD and public praise from huge equipment suppliers like Lam Research. That kind of outside validation is a critical sign that the world is buying into India's semiconductor dream.
So we end up right back where we started. One tiny chip, proven in the vacuum of space, represents a monumental leap forward down here on the ground. It proves a national strategy is working, it anchors a whole new industry, and it signals a new era of technological self-reliance. And that leaves us with one last really fascinating question to think about. With its first chip proven in space, what will India build next on Earth?